Hello, everyone. This lesson today is recorded as your multiplying rational numbers notes lesson. Take a look at the comic here for those of you who get it. Don't you think you guys should stop fighting? You're both being irrational. Pi is 3.14, on and on and on. The square root of 2 is an irrational decimal that doesn't terminate or repeat. And 8 is a whole number that is rational. So, yeah, kind of not funny. Here's our learning targets for today. Find products of rational numbers. By the end of this lesson, you should be able to explain the rules for multiplying rational numbers, be able to find the products of rational numbers with the same signs, and be able to find the products of rational numbers with different signs. So once again, just your product or your integer rules. Anytime we have the same signs, our answer is always going to be same signs, answer is always going to be positive. And if we have different signs, there the answer is always going to be negative. This team challenge was completed in class. We drew pictures to represent each of the fractions. How could you draw an area model to represent the multiplication problem? 3/4 times a half. We did this in class as well. We would split it up one way into a half. We'd split it up the other way into fourths. We would shade in 1/2 vertically, and we would shade 3/4 the other direction horizontally. And then you would look to see how many of the boxes were double shaded in. In this case, 3 of the 12 boxes were double shaded in. So 3/4 times a half is 3/12. How could you write a multiplication problem to represent this area model? A couple different ways that you could have done this. This was also done in class. Looks like we have 3/10, which is 0.3. And then we have 9/10, which is 0.9. Or, of course, you could have written it as fractions. 3/10 times 9/10. Now, here's our key ideas. To multiply rational numbers, use the same rules for signs as you use for multiplying integers. So just your integer rules. When the two signs are different, product is negative. When the two signs are the same, the product is positive. Here's our first example for you to just watch. We're multiplying rational numbers. Rational numbers are decimals that repeat or terminate, or fractions. And in this case, we have two decimals. We're following our integer rules. A negative times a negative is always a positive. So I know that my product is going to be positive, and all I have to do is multiply 3.75 times 2.4. Before I even start, I know that I have 3 digits after a decimal point. So in the end, I'm going to have to put 3 digits after the decimal in my product. So now we just multiply. 4 times 5 is 20. 4 times 7 is 28, and 2 is 30. 4 times 3 is 12, and 3 is 15. I'll cross off the 4 just so I remember not to mess with it anymore. I'm all done with that. And I put a place value in because now my first number is going to go down here for my second row. 2 times 5 is 10. 2 times 7 is 14, and 1 is 15. And 2 times 3 is 6, and 1 is 7. So now when I add these up, I end up with what looks like 9,000, but I remember that I have 3 digits after a decimal point, so I need to have my decimal point there, and I remember that I said negative times negative is a positive, so I'm going to just stick with 9. Here's another example of multiplying rational numbers, but this time we have fractions. I notice right away that I'm multiplying a negative times a positive, so I know that my product is going to be negative in the end. Now I can multiply these fractions just like I would any other time. let's turn 2 3/4 into an improper fraction. So 2 times 4 is 8, plus 3 more is 11. So I have 11/4 times 5/8. Now to multiply fractions, we just multiply straight across the numerators and straight across for the denominators. So I end up with 55 for my numerator, and my denominator is 4 times 8, so that's 32. From here, I can turn it back to a mixed number. 32 goes into 55 once. 55 minus 32 is 23, so that's my numerator, and I keep the denominator of 32. 23 is prime and it doesn't go into 32. So I'm going to stop there. And I'm going to also add in my negative because I know that a negative times a positive is a negative. Let's go ahead and make sure that we write this one down in our notes packet. Find negative 2.5 times 3.6. Sometimes we can estimate first. As you can see over here, it says estimate negative 2.5 times 4. 250 times 4 is about 10. So that just gives us an idea once we're done whether our answer is right or wrong based on the estimation. If our answer is like negative 50, we know it's wrong. If our answer is positive, we know it's wrong. All right, so go ahead and copy this one in your notes. I notice that we have a negative times a positive, so I know my answer is going to be negative. I have one decimal place in each number, so in my answer, I know that I'm going to have 2 digits after the decimal. And now I just multiply. 6 times 5 is 30. 6 times 2 is 12, and 3 more is 15. Now I'm done with the 6, so I put a placeholder in. 3 times 5 is 15. 3 times 2 is 6, and 1 more is 7. Now I'm going to add these up. And I get 900. But now in this situation, I had 2 digits after the decimal, so I'll need 2 digits after my decimal here. And my answer was negative because a negative times a positive is a negative. So in this example, I get a product of negative 9. I'd also like you to write down one example where you are finding the product of fractions. So let's make sure we write this one down. Maybe you listen to it and then pause it at the end and copy everything down. If we estimate 1/3 and we say that negative 2 3/4 is about negative 3, we could there estimate and say, well, 1/3 of 3 is 1. And then we'd also notice that a negative times a negative is a positive. So 1/3 of 1 is 1, and our answer is positive. So we know our approximate or estimate is going to be about 1. Now let's actually do the problem, and we'll see how it works out. So just like before, we want to write the mixed number as an improper fraction. So 1/3, we're good with that. But 2 3/4, let's turn that into a mixed number, or sorry, an improper fraction. So 2 times 4 is 8, plus 3 more is 11. So we actually get 11/4 there. And so now we're going to take 1/3 times 11/4, and we just multiply straight across. 1 times 11 is 11. 3 times 4 is 12. So that's how they got 11/12. And 11/12 is really, really close to 1. And a negative times a negative is a positive. So we're good to go here with our product being 11/12. Now it's your turn to give it a try. In your student journals, please pause the video and answer these 4 questions showing all of your work. Then once you've completed them, push play, and I'll go through each of the questions individually for you. Starting with question 1, I notice a negative times a positive, so my product will be negative. And I'm now just going to multiply 5.1 times 1.8. I also notice that I'll have 2 digits after a decimal point, so I need to keep that in mind as well for the end. 8 times 1 is 8, and 8 times 5 is 40. 0 for a placeholder, and 1 times 1 is 1, and 1 times 5 is 5. Now I add these up, and I get 918. I had 2 digits after the decimal point, so I need 2 digits after my decimal in my product. And I also said that a negative times a positive is a negative, so this is negative 9.18. For question number 2, I notice I have negative times a negative, which is a positive, and I have 2 digits after my decimal point again, so I'll multiply 6.3 times 0.6. 6 times 3 is 18, 6 times 6 is 36, and 1 is 37. I had 2 digits after my decimal point, so 3.78, and a negative times a negative is a positive. Question number 3. I notice I have a negative times a negative, which is a positive. So I'm just going to multiply 4/5 times 2/3, and I get 8/15. A negative times a negative is a positive. So my product is just 8/15. And then for question number 4, I'm going to turn both of these into mixed numbers into improper fractions. So 4 times 2 is 8, and 1 more is 9. 2 times 3 is 6, and 1 more is 7. So I have 9 times 7, that is 63. 2 times 3 is 6, and I can now turn that back to a mixed number. I can say that 6 goes into 63 10 times, with 3 left over, and a denominator of 6. And I can further simplify, divide by 3 over 3. 3 divided by 3 is 1. 6 divided by 3 is 2. So I have 10.5. Back to the original problem, a positive times a negative is a negative. So my product is actually negative 10.5. Before we move on to more examples, I need to stop here and review some of the multiplication properties. All right, so we've talked a lot about commutative property before. Commutative property, one of the ways that we remember that is commute means to move. So the commutative property means that for multiplication, that you can reorder your values to make them easier. So what I mean by that is if you had 3 times 5, that's equal to 15. You could also do 5 times 3 because that's 15. So you can flip-flop the numbers. Now, the associative property, the way I remember associative property is because associate means like who you're with or who your group is. Who's your group? And I put that in parentheses on purpose, actually, because associative property means that you can regroup your numbers or your values when multiplying. An example would be 3 times the quantity 5 times 2. Well, 5 times 2 is 10, and 10 times 3 is 30 if I do order of operations and I do what's in the parentheses first. But also if I regroup these and I do 3 times 5 in the parentheses and then multiply by 2, I'll get the same thing. 3 times 5 is 15, and 15 times 2 is 30. So associative property just makes you think, who are you grouping or how are you grouping your values? The multiplicative inverse is just when you have a fraction or a number and it is multiplied by the reciprocal. Here's what that means. If we have the number 1/2, the reciprocal is 2/1. And if we multiply 1/2 times 2/1, we would get 2/2, which is just 1. So in other words, anytime we multiply something by its reciprocal, we're going to get 1. So our definition here for multiplicative inverse is when a number is multiplied by its reciprocal. And then the multiplicative property of 1, that one just means that anytime you multiply by 1, you get the number you started with, or you get the same number. Negative 2/3 times 1 is just negative 2/3. So let's just watch this example because there's going to be a whole bunch of properties that we can use here. Okay? Let's just take a look first and notice a few things. I notice that I have negative 1/7 and I have negative 7. So that's telling me that I'm going to want to reorder these because I know already that negative 1/7 and negative 7, those are going to be reciprocals. So I want to reorder this and say negative 1/7 times negative 7 times 4/5 times negative 1/2. This makes things a lot easier for me because I know negative 7 is really negative 7/1. And I know now that I can associative property this. I can group these. And negative 1/7 times negative 7/1, that's just 1. And a negative times a negative is a positive. So that essentially then just cancels out, right? So I have 1 times 4/5 times negative 1/2. I can use the multiplication property of 1 here and the associative property. I can associate these two numbers together and I can say, hey, whatever I multiply these two numbers and get is going to then be multiplied by 1, and multiplying by 1 changes nothing. So I don't even really need to do that. So I can essentially then just multiply the numerators and denominators. 4/10, a positive times a negative is a negative, so that's negative 4/10. And then simplify, divide by 2/2, and I get negative 2/5. Now taking a look here, this is all multiplication, so I want to use the commutative property and I want to move and rearrange these. I want to do 0.01 times 1,000, and then I'll do times 2.7 times negative 3.92. 0.01 times 1,000, well, as a fraction, that's the 10th place and the 100th place. So this is 1/100th times 1,000. Let's actually do that first and put those in parentheses. 1/100th times 1,000. I'm actually just canceling out zeros there. and I get 10. 1 times 10 is 10, times 2.7 times negative 3.92. For me, I think I want to use the associative property here, and I want to group these. A positive times a negative is a negative, so let's keep that in mind, and let's just multiply 3.92 times 2.7. 7 times 2 is 14, 7 times 9 is 63, and another one is 64. 7 times 3 is 21, and 6 more is 27. Zero for a placeholder, and we multiply the 2 times 2 is 4. 2 times 9 is 18, and 2 times 3 is 6, and another is 7. Add them up. And I had 3 digits after a decimal point. So I get 10.584. And I need to multiply that times 10. Multiplying by 10 just moves my decimal point over, and I have 105.84. Now it's your turn. Please try it. Find the product of each of these expressions. Write your fraction in simplest form. And then once you've attempted both of them, push play again, and I'll talk you through the answers. Okay, things I noticed right away, and you didn't have to do it this way, but you could have used the commutative property, and you could have rearranged this. You could have done negative 2/3 times 3/2, and then times 7 and 7/8. And then you could have also done associative property, and you could have put parentheses around here, so we knew to do those first. What ends up happening is 2/3 and 3/2. Those are actually the reciprocal of each other, and anytime that you multiply by the reciprocal, you end up just getting 1, because 2 divided by 2 is 1, and 3 divided by 3 is 1. So you essentially end up with 1 over 1, which is just 1. Now in this case, it's a negative times a positive. A negative times a positive is a negative. So we end up with negative 1 times 7 and 7/8. Now we could use the identity property of 1 that tells us anytime we multiply something by 1, it's just that number. So we know our product is going to be 7 and 7/8, but we also know that a negative times a positive is a negative, so that product itself has to be negative. For number 6, I once again want to kind of just rearrange these. I want to do 0.1 and negative 10 together, and I want to do them first because I know that 0.1 is actually 1/10. So I want to multiply 1/10 times negative 10, and I want to do that first. Then I'll multiply by 100, and then I'll multiply by negative 5.3. Again, I want to do this because I know that I'm multiplying by the reciprocal. Negative 10 is negative 10 over 1. 1/10 times 10 over 1 is just 1. A positive times a negative is negative 1. So I end up with negative 1 there, times 100, times negative 5.3. The multiplicative property of 1 tells us that anytime we multiply something times 1, we just get that number. So 100 times 1 is 100, but a negative times a positive is a negative, so that's negative 100 times negative 5.3. Okay, so once again here, I'm seeing a negative times a negative. I know that is a positive. And 100 times 5.3 tells me I'm going to just move my decimal point 2 places to the right. and I get 530. A school record for the 40-meter dash is 15.24 seconds. Predict the school record after 15 years when the school record decreased by about 0.06 seconds per year. Use a verbal model to solve the problem. Because the school record decreases by about 0.06 seconds per year, the change in the school record each year is negative 0.06. So we have the current school record being 15.24. The number of years is 15. The average change is negative 0.06. Now we know through order of operations that we are going to have to do the multiplication first. So 15 times 0.06. 6 times 5 is 30. 6 times 1 is 6, and 3 is 9. And we had 2 digits after the decimal point, so this is 0.90, and a positive times a negative is a negative, so it's going to be negative 0.90, and it's 15.24 plus the negative 0.90, so really that is 15.24 minus 0.90. Oops. When we subtract, we get 4. We'll have to borrow or regroup. 12 minus 9 is 3. Bring the decimal point straight down. 4 minus 0 is 4, and 1 minus 0 is 1. So the school record after 15 years would be 14.34 seconds. Please write this example down in your notes after you've watched. A swimmer's best time in an event is 53.87 seconds. On average, his best time decreases by 0.28 seconds each of the next 5 times he swims the event. Does he accomplish his goal of swimming the event in less than 52.5 seconds? So we can do this a couple different ways. We can draw a table, and we can say 53.87 seconds is his best time. On average, his time decreases by 0.28, so we could do 53.87 minus 0.28. And that'll give us his time for the second race. So 17 minus 8 is 9. So 53.59. Then we'll take 53.59 and take away 0.28. And we get 53.31 seconds after his third race. Now 53.31 minus 0.28 to find the time of his fourth race. That's going to be 53.03. And then 53.03 minus 0.28. Whole bunch of regrouping and borrowing. 13 minus 8 is 5. 9 minus 2 is 7. And we get 52.75 for the fifth race. On average, if it decreases by 0.28 each of the next 5 times, does he meet his event? Oh, it looks like we need to go one more, because the next 5 times would be all the way to his 6th race. So now we're at 52.75 minus 0.28. So 52.47. After his sixth event, which would be after 5 more races, and it says his goal was to be 52.5 seconds. So we would say yes. Now, we could also write an expression. We could say 53.87, and then we're going to take away 0.28 times 5, because the next 5 events. So we would take 0.28 times 5. Eight times 5 is 40. It's 14, so we'd do 2 digits after a decimal, 1.40. So we could come over here and we could substitute this out and say, okay, this is now minus 1.40, and then 53.87 minus 1.40 gives us 52.47, and 52.47 is also what we got in our table by repeated subtraction. So we once again could confirm, yes, he beat his time.